Welcome back. So far, we've learned how to use if, elif, and else statements to make decisions. But what happens when decisions depend on other decisions? That's where nested conditionals come into play. They allow you to create multiple levels of decision making within your program. Imagine you are a restaurant manager deciding whether to seat a customer. Your decision isn't just a simple yes or no, it depends on multiple factors. Are there available tables? Is the customer dressed appropriately? Do they have a reservation? This is exactly how nested conditionals work in programming. It's like a decision tree with branches within branches. Now let's break down our restaurant seating scenario as a perfect metaphor for nested conditionals. First, you check if there are tables available. If tables are available, then you check if the customer has a reservation. If they have a reservation, you seat them immediately. If they don't have a reservation, you check their dress code. If they are dressed appropriately, they might get seated. If not, they will be politely turned away. So, what are nested conditionals? Nested conditionals are if statements placed inside of another if statement. They allow you to handle scenarios where one decision leads to another decision. As you can see from this basic structure of nested conditional statements you are looking at now, we have the first level of if and else statements with the primary condition. If the primary condition is true, the code inside the primary if block will be executed. And inside the primary if statement, we have the secondary if and else statement with the secondary condition. For the code inside the secondary if statement to run, that means both the primary and secondary conditions must be true. This is how nested conditional statements work. Now let's see this in action. So let's get rid of our example in our last lesson. So let's say we have two conditions. Let's call this our primary condition. Okay, so let's say primary condition is true for now. And we're also going to have secondary condition. Okay, so let's also say secondary condition is true for now. We are going to modify that later. All right, so let's say we have the first primary if statement. So we are going to say if primary condition is true. So we're going to print, okay. So we're going to print, we're going to have a string here. We're going to say primary condition is true, okay. Now we have the primary else statement. So here we are going to print, okay, we are going to say primary condition is, let's say false or not true, whatever statement you want to use. Now, inside of the primary if statement, we have another if and else statement, okay? So let's say if we have our secondary condition, okay? So if secondary condition is true, we are going to print, we are going to say both primary and true, okay? Now we have the else of this block. So we are going to say only primary condition is true. Okay, we can say secondary condition is false, right? So for this simple program we've written there, here we have the primary condition. If the primary condition is true, the code inside the primary if statement will be executed. If this condition is not true, then all this will be skipped and then move to the else statement. So if this condition is not true, then this line of code will be executed. Now, if this condition is true, this one will be printed and then we'll move on to the secondary condition. If the secondary condition is true, that means we are going to execute this line of code. But for us to be able to execute this line of code, that means both the primary and the secondary condition must be true. All right. So if the secondary condition is not true, so we are going to move to the else statement. So for this else block to be executed, that means the primary condition must be true, but the secondary condition is not true. So that is when this one will be executed. Let's run this now and see what we have. Okay, so you see primary condition is true. So that means this line of code is executed. And also secondary condition is also true. So this line of code is also executed. Now let's change primary condition to false. Let's change it to false. Okay, let's run that and see what we have. So we see primary condition is false. So all this line of code are skipped, and then this line of code is executed. Okay, so let's change this back to true. Okay, and then let's change secondary condition to false. Okay, so let's run this now and see what we have. So we see primary condition is true, so that's why this line of code was executed. But the secondary condition is not true, so this one was skipped, and then we move on to the next else block. So that is why this line of code is executed. So what you've just seen here is a typical way with which nested conditionals work. Using this knowledge of nested conditional statements, let's improve on our voting eligibility checker by adding an ID check. So now in this time, our user must have a voting ID in addition to being old enough to vote. Okay, so if you could remember our voting eligibility checker, let's comment this out. Okay, so I have the code in my clipboard, so I'm just going to paste that. Okay, so this is our current level of implementation to our voting eligibility checker. So now, in addition to be old enough to vote, we are going to add an ID check. So if the age of our user is greater than or equal to 18 years old, then we are going to ask our user. Okay, so we are going to say as a ID. We are going to say as ID. We are going to ask our user. We are going to input. So we say, do you have a voting ID? So it's a question. All right, so what do we expect from them? We're going to say they should type either yes or no. We need a / here, yes or no. So that's what we require from our user. So here we have a colon, right? Okay, so after that, we're going to say if or as ID is equal to yes, okay? Then we're going to say, we're going to nest this inside of it. Let's bring this up. This will be nested inside of the if statement. So if our user has a voting ID, then you are going to say, yeah, you are eligible to vote. Else, we're going to say else. So now we're going to print. We're going to say you need an ID to vote. But there's a little problem with our implementation there, because here we need the user to either enter yes or no. There's the possibility that our user might enter yes or no in uppercase. Okay, let's run this and see what we have. So you see, are you old enough to vote? Enter your age. Let's say I'm 19 or 29. So 29 is eligible to vote. Now I'm going to enter yes in uppercase. So I'm going to say yes with uppercase Y. Okay, so I run that. You see, even though our user entered yes, the condition is still not true. Because the condition was not true, that's why this line of code was executed. You see, we have you need an ID to vote, whereas the user is saying yes. So now what we need to do is we need to turn whatever input the user is giving us, we need to turn it all to lowercase. So to turn it to lowercase, we are going to use the lower method. We are going to see dot lower, all right? So now this is going to turn whatever input our user is giving us, is going to turn it all to lowercase. Okay, so let's run this again. All right, so are you old enough to vote? Let's say I'm 19 now. Do you have a voting ID? Let's say yes. Now I'm typing uppercase Y. So now you see that our condition is true. So that's why we have, yeah, you are eligible to vote. Okay, so this method is turning whatever input the user is giving us to lowercase. All right, so let's run this again. Okay, are you old enough to vote? Let's say I'm 19. Okay, so then let me say no, I don't have a voting ID. So if I enter that, that means the condition is not true. So we are going to have this line of code executed. You need to have an ID to vote. So this is how nested conditionals work. The first condition must be true. If the first condition is true, then we move on to the next condition. If the next condition is true, the code inside the secondary conditional statement will be executed. If not, we move on to the else block of the primary conditional statement. Okay, so let's run this again and say we are less than voting age. Voting age, let's say we are 17. Right, so let me enter that. So you see, sorry, you can't vote yet, which is the code from this line. You have 1 year until voting age. You can also make modification to that. You can do that on your own, so that S will only be added if age is greater than 1. We have nested conditionals in use in many areas of real-life applications. In something like banking system, we can also implement a simple ATM withdrawal scenario. For example, when a user wants to make a withdrawal from their account, first we are going to get the amount the user wants to withdraw from an ATM machine. Then we check if the user has up to that amount. After that, we ask the user should confirm their withdrawal, and then the transaction is going to be successful if all conditions are met. All right, so let's comment this out if you want to implement that. Okay, so we're going to comment all of this out. Okay, so the first thing we are going to we are going to indicate to the user, let's welcome the user to our bank. So we are going to say, welcome to the Python bank, right? So let's welcome our user to our bank. Okay, so let's create a variable called balance to mimic the balance of our user. Let's say our user currently has $1,000. All right, now we're going to get the amount that the user wants to withdraw from their account. Okay, we're going to say amount is equal to, we're going to turn that to an integer, and inside of the integer we're going to have an input function to get the amount that the user wants to withdraw. So we're going to pass a prompt to the user. We're going to say enter withdrawal amounts. My withdrawal is not correct. Withdraw okay, we enter withdrawal amount. All right, so we're going to get the amount the user wants to withdraw. Now we are going to check if the amount the user wants to withdraw is less than their account balance, because we are not going to allow the user to withdraw more than what they have in their account balance. Now we are going to say if amount is less than or equal to balance, right? So if the amount is less than or equal to balance, we are going to execute a line of code there. So else, if the amount, if what the user wants to withdraw is not less than their balance, we are going to print. So we are going to say insufficient balance. Right, now let's implement the code that will be executed if the user has sufficient balance. Okay, so if the user has a sufficient balance, then we are going to confirm. We're going to confirm if the user actually wants to make the withdrawal. So we are going to input. We are going to say confirm withdrawal. Okay, so what we need from the user is either a yes or a no. Okay, so we are going to turn that to lower in case the user is pressing yes or no in capital letter. Okay, now if the user press yes, so we are going to say if or confirm. If confirm equals the string of yes. Okay, so if our condition is true, we are going to print to the user. So we are going to say let's say withdrawal successful. Correct with my withdrawal spelling. Okay, so we say withdrawal successful. Else, okay, so we are going to say else. That means if the user press no, we are going to say let's print to the user. We are going to say withdrawal cancelled. Okay, cancelled. All right, so this will be the implementation of our simple ATM withdrawal process. Let's run this now and see what we have. See, welcome to the Python bank, enter withdrawal amount. Okay, so let me say I want to withdraw 1,200, which is greater than what I have in my account. So let me run that. You see, I have insufficient balance. Let me run it again. Enter withdrawal amount. Now let me enter 800. 800, if I enter that, confirm withdrawal. So if I say yes, withdrawal is going to be successful. Let me run that again and say no. Okay, so enter withdraw amount 800. Okay, so I'm going to say no. Okay, so withdraw cancelled. Right, so this is a typical nested conditional statement where one condition is dependent on another. If we wish, in this example, we can also add another level of nesting to our conditionals. So we can request for our user to provide PIN before granting them access to perform any operation. So to do that, we can as well get the PIN of the user. Let's define a PIN for our user. Let's say the PIN of our user is 1234. Okay. And then we are going to ask the user to input their PIN. Let's call this input PIN. That is the PIN the user is going to provide them. So we are going to say input, right? So we are going to say, what are we going to pass to the user? Let's say enter your PIN. Okay. Enter your PIN. Now we're going to check. We're going to check if input PIN equals PIN, right? So if it is correct, that's when we are going to allow the user to perform all these operations. So we are going to nest all of this inside of the first conditional statement. Else, so if the input PIN is not correct, so we have else, the ground else. We're going to say, we're going to print to the user, going to print incorrect, going to say incorrect PIN. All right, so let's run this again. Welcome to Python Bank. Enter your PIN. Let me enter a wrong PIN. So let's say 2345. Okay, so you see incorrect PIN. Now let me run this again with the correct PIN. I'm going to say 1234. Okay, what do we have as our PIN? Okay, our PIN is integer, whereas our input is going to provide string. So we can as well convert this to integer, or we can turn this to string. Whichever is the case, we can use any of the scenarios. Okay, so let's run it again. Okay, enter your PIN, right? So I'm going to say 1234, right? So enter your withdrawal amount. Let's say 700. Okay, so confirm withdrawal. Yes, should be yes, right? So withdrawal successful. This is how nested conditionals work. Take note that when dealing with nested conditionals, always ensure nested blocks are indented correctly, as Python relies on proper indentation to group your code. Also, avoid deeply nested conditionals, as they can make your code harder to read. As you can see, even with this simple implementation, that our code is already getting clumsy. So imagine having more nested conditions. So try to always simplify your code as much as possible. Keep nesting to a maximum of 2 to 3 levels and add comments to explain complex logic. Okay? In the next lesson, we'll introduce loops, a key concept for handling repetitive tasks in Python. See you there.